See if we get that full screen. Uh-oh, before we even begin. Oh, I think we're gonna be okay. All right, I don't know, the shape of a banana, I guess, is a little bit quadratic with that. There's other things in the world, as you know, that have that quadratic, that parabola shape. Here's your quadratic formula. The solutions of a quadratic equation in the form ax squared plus bx plus c equals 0, where a is not equal to 0, because then you'd be dividing by 0, and we can't have that, are given by this formula. And how do we remember this formula? Oh yeah, we're going to have to sing this in class, but x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and then that gets in my head. I just want to point out a couple things here. Normally it's ax squared plus bx plus c. The only difference here is sometimes we don't use x as our variable. Well, that's fine. Your a value in this case is negative 4.9. So you may have to take a moment, write out a equals, b equals 3, and c equals 10. Please note, we always start with negative b, which means if b is 3, then negative b is going to be negative 3. If you have troubles with this, I will have you write it out like this. Please note also in here we have b squared. Anytime you square a number, whether it's positive or negative, it will always come out positive. So the first number under the radical should be positive, and I still have issues with that because you type into your calculator, you don't type parentheses, and then it follows the order of operations, but it's not what you intended with the way you type it in. All right, let's actually do a problem. All right, this is example number 1. We want to solve this by using the quadratic formula. Just like factoring, you cannot solve unless you have it set equal to 0. So, I better change the color on that, otherwise you will not see a thing. X squared minus 8x minus 33 equals 0. So I subtracted 33 from both sides of the equation before I can do any other math. All right, off to the side. You probably won't always have to do this, but we'll start. Your a value is 1, not x squared, just 1. It's the coefficient, the number in front of x squared. B is equal to negative 8, c is equal to negative 33. If b is negative 8, then negative b is 8. I do this because the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I like to put parentheses just because it clarifies a few common mistakes. All right, negative b, well, b is negative 8, so negative b is 8. Plus or minus square root, b squared. Don't even use your calculator. What's negative 8 times negative 8? 64. Notice how that's positive. It'll never be negative. I mean this number right here, not meaning the whole thing here. Minus 4 times a. A is 1. C is negative 33. All over 2a. All right, and that's what the x values are going to be. All right, then we keep moving on here. I would condense, first of all, what's in the parentheses. 8 plus or minus square root 64 minus, what is 4 times 33? So is it like 132? Let's see. Is 132. So I have minus, that's this minus, this is negative 132. All right, over 2. What do? I keep going. I condense. Oh, it's reaching up here. All right, 8 plus or minus. Square root is 64 plus 132. I don't know, maybe I don't need a separate step for that. I'm going to keep going though. 8 plus or minus, let's see, 132 plus 64 happens to be square root of 196. And what is the square root of 196, you're wondering? It's 14. So now, instead of writing square root of 196, I'm going to write 8 plus or minus 14 over 2. Now, you're going to have to do this 2 separate answers. You're going to do 8 plus 14 over 2, which gives me 22 over 2, which is 11. And if you go the other way, you do 8 minus 14 over 2. That means plus, there's no button, there's a button on your calculator, but you cannot do this mathematically on your calculator, then poof, have both answers come out at you. Okay, so we have negative 6 over 2, which gives you negative 3. All right, so your solutions, otherwise known as roots, zeros, x-intercepts, are at 11 and negative 3. Now, hopefully, 11 and negative 3. That means this is a smiling parabola. I'm going to look at this one. Smiling parabola, y-intercept at negative 33. Your x-intercepts are 11 and negative 3. That's what quadratic formula does for you. It helps you find those solutions. All right, let's try another one here. A is equal to 1. B is equal to negative 34. C is 289. Whoa. All right. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals positive 34 plus or minus b squared. So 34 squared is 1156 minus 4 times an a value, which is 1, times a c value, which is 289. All over 2 times the a value, which is just going to be 2. Okay, so 289 times 4 is 1156. So I have 34 plus or minus the square root of 1156 minus 1156 all over 2. Well, what does that give me? It gives me 0. Okay, the square root of 0 is also 0. I don't want to be considering that I'm completely skipping a step. So really, 34 divided by 2 is 17. This means our parabola smiles. Okay, it's actually shifted to the right a little bit. And we have a y-intercept way up here, 289. And here's your x-intercept is 17. This is not to proportion at all. That means we only have one solution, one root. All right, we're going to do it one more time. A equals 1, B equals negative 6, C equals 2. I'm going to sing it one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yeah, I'm going to sing that so it is in your head so that you have that down. All right, x equals negative b. B is negative 6, so negative b is 6. Plus or minus b squared. Don't even grab your calculator. Negative 6 times negative 6, positive 36. That number is positive. Minus 4 times a times c divided by 2 times a. All right? So now I have 6 plus or minus square root of 36 minus 8 divided by 2. 6 plus or minus the square root of 28 over 2. Now, you will have to listen to the instructions or read the instructions. I'm going to go 2 decimal places. 6 plus or minus 5.29 over 2. This means I got to go both ways. 6 plus 5.29 over 2. 5.29. I usually press enter and then I divide by 2, or on your calculator you need to put a parenthesis. Then I get 5.645, which I'll put down as 65. Then I do the minus. 6 minus 5.29 over 2. Okay, once again, either you put parentheses or you press enter and then divide by 2. I get 0.355, which I'll put down as 0.36. This is where your parabola will cross the x-intercept if you graph it out. Okay, I don't know. Do I want to do another one? I think I'm going to very quickly at least get you started. I need to, set it equal to 0. I do that by subtracting 6x from both sides. And because we like to go in order, y equals ax squared plus bx plus c, this is what I get. X equals negative b, switch the sign, square root of b squared minus 4 times a times c divided by 2 times a. Here's the cool thing that starts happening with this one. I just want to work this one through. 36 minus 13 times 4 is 52. Now, way back in Algebra 1, you would have come across this next step and done this little thing. 36 minus 52 gives you a negative 16. And you would have been like, whoa, negative 16, I can't do that. My calculator won't let me do that. Oh, but now that we're in Algebra 2, and we know that the square root of negative 16 is now, oh yeah, you can't forget the information we just spent, well, it seems like forever because we started probably before Christmas, is 4i divided by 2. These are all even numbers, so 2, every number is divisible by 2. So 6 divided by 2 is 3, plus or minus 4 divided by 2 is 2. Keep the I, and then I could write it over 1, or you could just write 3 plus or minus 2i. So you have a complex number. This is what happens when your parabola smiles. It has a y-intercept of 13. It looks like it's moved to the right. It must do something like this. There are no rational x-intercepts, but we have imaginary x-intercepts. I should not say rational, I'm going to say real. Okay, discriminant. B squared minus 4ac, that's that part underneath the radical. Okay, if it's greater than 0 and it's a perfect square, I would do it quick. I'm going to go through this really quick, but you're going to have to press pause. You have 2 real rational roots. It looks like this. But if your b squared minus 4ac is not a perfect square number, and remember the perfect square numbers are like 1 times 1 is 1, 2 times 2 is 4. So 1, 4, 9, 16, 25, 36, etc. If it's not perfect square, then we say they're real but irrational. B squared minus 4a is 0, because we had an example of that, then you only have 1 root, 1 solution. And if the number is less than 0, then you get like a square root of the negative 16. We say we have 2 complex roots. And in fact, on this last one, you're like, 2 complex roots. One of them was 3 plus 2i. The other one is 3 minus 2i. So that's actually 2 complex rules. Complex has a real part and an imaginary part. All right, this one's already kind of written out. Here is the discriminant. Here's your quadratic. Describe the number of roots. Here's your ABC. This time you don't even have to go through the whole quadratic formula. You work it through, you get negative 11. The discriminant is negative 11, so there are 2 complex roots. I don't like to spend a lot of time talking about the discriminant because usually you're trying to find the solution and then you either figure it out because you did the quadratic formula and you say, hey, these are my 2 complex roots. All right, now let me see if I showed you one here. I've got another one that laid out exactly the kind of the same thing. When you put in b squared minus 4a squared, you have to do your math correctly. You get 81. What does that mean? You have 2 rational roots because this is a perfect square number. If it wasn't perfect square number, then you would have to put down 2 irrational roots. Okay, like you would have those, we had like a 5.63 or whatever, you had to like round it. Okay, and here we got find the value of the discriminant for x squared plus 8x plus 16 equals 0. B squared minus 4ac. So I've got b squared, which is 64, because I take 8 squared, minus, I'm going to put that in parentheses again, the a value is 1, the c value is 16. So I have 64 minus, believe this or not, this is 64. So I get 0. That means I have 1 rational root. Let's go back and look at the chart. So you go back, and if your discriminant is 0, you have 1 real rational root. Okay, if we do this again, b squared, let me write it out again, b squared minus 4ac. That might be more for me than for you. B squared would give you 9. Negative 3 times negative 3 is 9. Minus the 4 times the a times the c. All right? So we have 9 minus 16 times 6 is 96. So this actually ends up being negative 96. So now you have minus for this one right here, and the number inside is negative. So you're going to add them together, and you're going to 105. Okay, so I have a real number here. It is not a perfect square number, so we're going to have two irrational roots. If you need to go back and look at that chart, please go ahead and do so. Okay, this is an overall summary. How can you find the solutions of quadratics when you graph? You can sometimes do this. The only thing is sometimes it's hard for a graphing calculator to always give you the exact answers. Factoring works some of the time. Square root, we didn't talk too much about square root property with this. We did not do complete the square. And quadratic formula works all the time. I think you need to put this part of the chart down. Leave this out.
Jacob Mikulski, Jason Kaminsky Horak.
All right, and that's the end of the lesson.
Tyler Haas, Connor Hatfield, Cody Drake, Chris Bernard, and Brady Anderson.